Zero Duration Timer Idiom and CrossFit Cindy. Shlaer-Mellor Days 2024. Hello, I'm Cortland Starrett of One Fact. In this presentation, I want us together to explore an intriguing work pattern found in life and computational systems. We will first understand the work pattern, then we will model an example application that demonstrates it. Then we will explore the challenges that it poses to Shlaer-Mellor modeling. Lastly, I will propose a small change to the Shlaer-Mellor method to make life simpler for this particular work pattern. So, on we go. But first, let me ask 3 provocative questions. I will give my own answers at the end of this presentation, but I want you to answer them for yourself now. Go ahead and write them down. Commit them to the chat, or simply keep them in your mind. Answers are yes or no. Should the modeler control when an event to self is expedited? Go ahead and think of an answer. Does a timer with a duration of 0 mean something special? Is a delayed event to self expedited? Again, give your answers and we'll review them at the end. Back to the work pattern. There's a work pattern that I sometimes encounter. It probably has a name and has been written about somewhere and I don't know about it, but it poses a minor challenge to Shlaer-Mellor modeling. Allow me to describe it and explore the challenge. It has to do with working as hard as you can. There are 3 forms. Work as hard as you can for a prescribed amount of time, work as hard as you can until I tell you to stop, or work as hard as you can until somebody else tells you to stop. A nice example of the work pattern is visible in the fitness world. I like to exercise and am a member of a CrossFit gym. Yes, I am one of those. You may be a CrossFitter or no one because CrossFitters talk about it all the time. Some claim that CrossFit is a cult. In fact, I entered a pub and sat in a bar next to a vegan, a political activist, and a CrossFitter. How did I know? Because they all told me in the first 5 minutes that I was sitting there. Okay, let me tell you about one workout in particular. It is called Cindy. CrossFit likes intensity, so most workouts are timed. These timed workouts come in 2 flavors, fixed volume and fixed time. In a fixed volume workout, the volume of movement is fixed, but the athlete is expected to complete the workout in the shortest amount of time. In a fixed time workout, the duration of time is fixed, and the athlete completes as much work as possible in that fixed time. A popular fixed volume workout is called MRF, named after a fallen soldier, U.S. Navy SEAL Lieutenant Michael Murphy, who died in battle in Afghanistan in 2005. It's a tough one and involves run 1 mile, do 100 pull-ups, 200 push-ups, and 300 squats, and then run another mile. The volume of work is fixed and the time to complete it varies. This could be described as work as hard as you can until you have completed all of the repetitions. However, it is the fixed time mode that I want to explore and model. In CrossFit speak, this is called an AMRAP, as many reps as possible in the prescribed time duration. Okay, let me tell you about one workout in particular. It is called Cindy. Do 5 pull-ups, then 10 push-ups, then 15 squats, and repeat for 20 minutes. Your score is the number of reps, that you complete within the prescribed time of 20 minutes. Here is a visual example of me and Ezra doing a couple of rounds of Cindy.
3, 2, 1, go.
Bluetooth connected.
Keep going. One more.
Good job.
All right, now hop down and do the push-ups. 10 push-ups. Two more. One more. Now 15 squats. All right, hop up. Whoops. All right. Two more. Try one more, jump. Nice. All right, on the push-ups.
That's a round and a half.
Time.
Later, I will list other examples of this pattern in information systems. But for now, there is one related to chess. In Levi's chess bot, he has a limited amount of time to explore future moves and select the best move he can. The deeper the bot can look into the future, the better move candidate he will find. But he is limited by time, so his bot works as hard as it can to find a candidate move until it gets interrupted. In this respect, it is kind of like the Cindy workout. Here is the Cindy class diagram. We have a gym that hosts a gym class. We have a coach coaching an athlete, and we have a workout with two subtypes for the fixed duration and fixed volume workout. A coach coaches many athletes. An athlete performs one workout. Lots of refinement can be made here, but I need only the athlete class to demonstrate our work as hard as you can AMRAP work pattern. And here we have the state model providing the life cycle of the athlete class. And we have the ready state, which is where we start. When the coach yells 3, 2, 1, go, the athlete transitions to the pull-up state and does a pull-up and adds 1 to his repetition count. He then transitions back to the same state and does another pull-up and another pull-up and another pull-up until he has done 5, incrementing his rep count each time. At the end of the state, the athlete generates either A2 repeat, this transition, or A3 next movement. And those events are generated to self. The athlete then transitions to push-up, repeating the push-up state until he has done 10 push-ups, moves to the next movement and into the squat state, and he repeats the squat state until he has done 15 squats. The athlete then transitions back to pull-up and starts all over again. The loop of states repeats as fast as it can until the 20-minute time duration is over. The time event coming from the coach, that's this event here, generating A4 time to each athlete in the gym. At this point, the athlete should transition to the resting state from whichever movement state he is in. Note that time can run out in the middle of a movement. For example, the athlete may have performed only 3 of his 10 push-ups when time runs out. That's good because every rep counts. Some athletes will go fast, some will go more slowly, depending on fitness level, but they all go as fast as they can. Does this seem reasonable? Does anyone detect a problem? There is indeed a problem. This state machine does not work. It does not work due to a Shlaer-Mellor event rule governing the delivery of events directed to self. Specifically, the time event, A4 time, will not be received. This will result in the athlete continuing to do pull-ups, push-ups, and sit-ups forever and ever. It is an endless loop. In the OOA 96 report, the Shlaer-Mellor method was revised to treat events generated to self differently from events coming from other instances. Events generated to self are received by the object state machine ahead of events from other instances. Why was this added? The rule is intended to help maintain data access set consistency. The rule allows an object to sequence through multiple states before arriving in a state in which the instance population is in a stable and cohesive condition. It can also simplify a state machine such that it does not need to respond to every type of event from every state, namely transitory states. Some modelers refer to these intermediate states as transitory states. I know of one modeler who shades these states with a different color to highlight the difference between transitory states and stable states. Expedited event to self allows complex state models to be substantially simplified. The rule is a good rule, but would be better with a small tweak. So, where's the gap? Every event to self is expedited even when not on a transition to a transitory state. This effectively makes it impossible to generate an event to self without it being expedited, even if the modeler does not want it expedited. This is the case with our athlete object in the model of Cindy. None of the states are transitory. None of the events need to be expedited. We need a way to expedite only when we have transitory states, or we need a way to indicate that we do not want an event to be expedited. Other examples. In the protocol verifier, we process audit events as fast as we can until something tells us to stop. In a performance benchmarking application, a benchmark tests the speed of an operation. The operation may be very short, so the benchmarking application repeats it many times for a fixed period of time and then divides by the rep count to get the operation time. Again, working as fast as it can for a specific period of time. In packet reception applications, we're often receiving packets or bytes, but we need to honor a guard timer that is able to interrupt our state machine. I recommend that we revise the expedited event to self rule to allow a keyword to activate or deactivate it. I would be happy with a keyword that could be used on the generate statement and would only be valid when generating to self or this. Since we have history of defaulting to expedite self events, the keyword might be unexpedite. But I might prefer to see the default behavior be to not expedite. Thus, I prefer a keyword, expedited, to only expedite events when explicitly requested, in the case of transitory states. Let us explore this change to the method, through due process, using our OOA modeling subcommittee, and explore options out in the open. Meanwhile, modelers have been working around the expedited event to self rule for many years. I suspect the gap in the rule was not discovered until model compilers implemented it and modelers began running their models with it. If we break the single state machine into two state machines, we can work around the expedite rule. Consider splitting our athlete into head and body. After each rep, the body could ask the head if we are done yet. This works, but would make our quite natural model a bit awkward. In a similar fashion, we can work around the expedited event to self rule by introducing a subtype-supertype hierarchy and leveraging polymorphic events. If we add a supertype to our class, we could generate to self when we desire the event to be expedited, generate to the supertype when we don't. Again, this works, but is awkward. The MC3020 architecture expedites events generated to self when it detects the self keyword in the generate statement of the action language. Here is an example of assigning self to a transient before the generate statement. This does not work in Bridgepoint Verifier, Sierra, or Mazel C++, since these architectures check the ID of the sender and receiver and expedites when they match. So this cute little hack works only when running the MC3020 model compiler. The final workaround is my recommendation to be in the preferred idiom going forward until we update our action languages. This looks strange. Why in the world would someone have a zero duration timer? Notice a timer is being started with a duration of 0. Since all known architectures deliver timer events normally, that is, not expedited, this approach works in all the cases I know of. The statement is so ugly looking that it draws our attention. This is kind of good since we are using it as a temporary workaround. Architectures can and do recognize and optimize this statement and simply deliver the event, normally unexpedited, without actually starting a timer. Speaking of ugly looking, here is the zero duration timer idiom as represented in the Mazel dialect action language. The @PT0s is the zero duration immediate data value. There should probably be a comment here drawing more attention and explaining the idiom. For now, my recommendation is to use the zero duration timer idiom.
Sweetheart, I'm home.
Hi! Before dinner, would you like to hear my opinion on the zero duration timer idiom?
Yes, please.
Okay, back to the questions. See if your answers have changed. Should the modeler control when an event to self is expedited? Yes, it should be the exception, but for certain patterns, as described above, it is difficult and clumsy to build a model without the ability to circumvent this rule. Does a timer with a zero duration mean something special? Yes, it does. It means the modeler is circumventing the expedited event to self rule. Such timers may be optimized to simply deliver the event immediately, but without expediting. Is a delayed event to self expedited? No, since modelers use zero duration delayed events to circumvent the expedited event to self rule, timer events must never be expedited. And delayed, expedited, those two terms are kind of contradictory. So, how did your answers match up? Summary. The OOA 96 rule to expedite events directed to self introduced the potential to lock out events from other instances and timers. The Shlaer-Mellor community should consider a small change to the rule to be used judiciously. Workarounds exist. Let us agree on a single workaround until the method and action languages support the revised rule. Thank you. I hope this presentation was informative and fun.